Hey guys, it's Mr. Martin. I'm going to be doing page 200, 201, problem number 13, 29, and 48. So the directions for number 13 says use analytic methods to find the extreme values of the function on the interval and where they occur. Identify any critical points that are not stationary points. Alright, so first thing we're going to do is we're going to find a critical point by finding the derivative. H prime of x equals 1 over x plus 1 times the derivative of x plus 1, which is 1. So we make that equal to 0. 1 over x plus 1 equal to 0. If we multiply both sides by x plus 1, that cancels out, and we get 1 equals 0. And we know that's not true, so there is nothing that makes the derivative equal to 0. But if we look back at here, the derivative is undefined at x equals 1. So because we have a closed interval right here, 0 to 3, we have what we can use the extreme value theorem. Extreme value theorems, because we're a continuous function and on a closed interval. Therefore, we know we have one maximum and we have one minimum. Our endpoints, f of 0, our critical point, f of 1, and then our other endpoint, f of 3. We're just going to test those and see which one is a maximum. F of 0 gets us the natural log of 1. The natural log of 1 is 0. Then we plug in the next one. We get the natural log of 1 plus 1, which is the natural log of 2, which I don't know what that is off the top of my head. And we plug in the right endpoint, natural log of 3 plus 1, which gives us the natural log of 4. So we know this is the smallest y value, this is the largest y value, so this is going to be our minimum, this is going to be our maximum. And then we use our little cheat sheet. We have a maximum, not cheat sheet, but sentence, maximum of the natural log of 4 at x equals 3, and a minimum of 0 at x equals 1. So those are our two extreme values. Alright, so now moving on, we got y equals x over x squared plus 1. This one, basically the same rules. Find the extreme values of the function and where they occur. So we're going to take this, we're going to take the derivative, y prime equals low x squared plus 1 d high minus high x d low, which is 2x, all divided by x squared plus 1 squared. Clean this up a little bit. This gives us x squared plus 1 minus 2x squared all over x squared plus 1 squared. X squared minus x squared, or minus 2x squared, is y prime equals negative x squared plus 1 divided by x squared plus 1 squared. We make this equal to 0. Negative x squared plus 1 equals 0. Subtract 1, subtract 1. Notice I'm just doing the numerator because the denominator is going to tell us when it's undefined, and the numerator tells us when the derivative is equal to 0. So we subtract 1, we get negative x squared equals negative 1, so x squared equals 1, therefore x equals plus or minus 1. We make the denominator equal to 0. X squared plus 1 squared equals 0. Nothing in there is going to make that 0 because of that x squared. We can't get that to be a negative 1, so we just say nothing. So now we have critical points at x equals 1 and x equals negative 1. And what we want to do is we want to figure out, are these maximums or minimums? So there's a bunch of different ways we can do it, but we're going to look at just our little sign chart. That's what we did in class today. Negative 1, 1. Okay, we look at our derivative function. Our derivative is y prime equals negative x squared plus 1 all over x squared plus 1 squared. Now the bottom is always, no matter what point we plug in there, the bottom is always going to be positive. So we just need to test the top. We plug in negative 5, and that's going to give us negative 25 plus 1, which makes everything in there negative. Plug in 0, that makes that 0 plus 1, makes that all positive. It makes that all negative. So we look at the point x equals negative 1. We say, oh, at negative 1, the function was decreasing. Then it hit negative 1 and it became increasing, so that makes that a minimum. And then this a maximum. Now we just got to plug those points back into our equation, our original equation, and that'll give us our answer, our y value. So negative 1/2 is going to be our minimum, and f of 1 is going to be 1 over 1 squared plus 1 equals positive 1/2, and that's going to be our maximum. So if we were going to write this out, we have a minimum of negative 1/2 at x equals negative 1. We have a maximum of positive 1/2 at x equals positive 1. That's our two answers. Alright, and then the last question we're going to do is number 48. It's a multiple choice. I wrote out all the answers, or I wrote out the question here so we can see it. If f is continuous decreasing function on 0 to 10 with a critical point at 4, 2, which of the following must be false? So lots of keywords in here. We've got continuous, we've got decreasing, we've got a closed interval, so that means EVT. Alright? Continuous and closed interval. Critical point, so critical point means that f prime of x, or f prime of 4, equals 0 or undefined. We don't know which one. And then which of the following must be false? And so we want to make sure we focus on that word false. It has to be false. There's no way it can be true, because which of the following must be false means it always is false. If it said could be false, then it's a little bit harder of a question. So the first one says f of 10 is an absolute minimum of f on 0 to 10. So this brings us back to this word right here, decreasing function. It says it's decreasing on the whole interval. So there is no way for us to draw a function that's decreasing on a closed interval using the EVT that doesn't have the right endpoint be its minimum. So f of 10 is absolutely an absolute min. F of 4 is neither a relative maximum nor a relative minimum. So up here we said it is a critical point. Okay, but remember, like in an x cubed function, at that point right there, x equals 0 is a critical point, but just because it's a critical point doesn't make it a max or a minimum. So f of 4 is neither a relative maximum nor a relative minimum. That's possibly true, so we can't use that one. F prime of 4 does not exist. Well, when we said critical point, we said f prime of 4 equals 0, or it does not exist, so that could be true, which leads us to D, f prime of 4 is 0, so that one could be true. So our only possible answer is f prime of 4 is less than 0. We know because it's a critical point, it has to either be equal to 0 or does not exist, so that means it cannot be less than 0. Alright guys, as always, if you have a question, email me at jaredsmartin@gmail.com.